The plan, like every week, we are going to watch my latest video release. And if you have any questions, you can ask them while we are watching. And I will also add more context and talk about different things that maybe clear up some parts of the video. You know, these videos are very condensed. I decide to leave, to cut certain parts out, to not explain certain things. And the stream is the opportunity where I can share those thoughts as well. So this is going to be like, I don't know, the original video is like, I don't know, 10 minutes. This will be like an hour or something like that, okay? At least experience has shown that. Without further ado, I guess, it's called Do Not Use Alert 1 for XSS. It's very clickbait. This video was actually basically sponsored or paid for by Google because maybe you have seen on Twitter that Google has released or, created their new platform here. Let me show you. Wait, there you go. The Bug Hunter University. There's a question if the Bug Hunter University site also teaches bug hunting. Here, this article about XSS in sandbox domains, it's explaining to you why this is an invalid report. And you maybe wonder yourself, why would I care about invalid reports? I only want to learn about valid reports. I want to learn about valid XSS. Why should I care? But reading and understanding this, you will understand also valid reports. You will understand valid XSS issues, right? It makes you a bit more critical and like, it is super educational, right? So I'm not saying this is the ultimate platform to learn bug bounty hunting. This is obviously not the case, but what I'm saying is this is just a very unique place because I think resources on what are invalid bug reports are very sparse. It's unique. I think it's special, compared to all the other resources, including my own channel that you can find online. It's always just about valid bug reports and vulnerabilities and rarely or never about things that are just not vulnerabilities. Yeah, let's head into the video.
Alert 1 is the typical JavaScript payload to prove that you found a cross-site scripting security vulnerability. And in this video, I want to explain why we use alert in the first place, but also why you should not use alert 1 and instead use alert document.domain, alert window.origin, or maybe even console.log. This is very important to understand when you are hunting for XSS issues, especially on very modern web applications. It allows
The thing is why Google is asking you to use this. There's obviously technical reasons that we go into, but even if you as a bug hunter, you're just starting out and you don't really understand like XSS and the impact of XSS yet, alerting the domain or the origin, basically it's kind of like the same thing in some sense, is, while it's not telling you much, it's telling the experienced Google triager a lot. By knowing where the alert fires on what kind of domain, basically it eradicates any question if this XSS has impact or not, because Google triagers will know that this particular domain has impact or not. This domain is a XSS sandbox or not. So even if you don't understand why you should use it, just use it because it will help the triagers.
When you are hunting for XSS issues, especially on very modern web applications. It allows you to assess the impact that your XSS has, and so it's crucial to determine if you actually found a critical vulnerability or maybe an invalid issue. So first of all, why do we use alert? Actually, I don't know historically why, but it has two huge advantages. First of all, the obvious, it's very visual. If you randomly try to put XSS payloads in various input fields and then continue to browse a website, you might just see an alert pop up, which means you don't need to carefully investigate each input. This is why XSS can be very simple to hunt for, at least the basic XSS cases. It's as simple as spray the input around and pray that an alert pops up. But there is another advantage to alert. There are some browser client-side JavaScript frameworks with templating features allowing some limited form of JavaScript. And you can imagine that if you have input where
so there was so it makes the work of the triage easier, but it makes also the work of your own bug hunting easier once you understand why that matters. So once you understand why it matters that you alert the domain, you will, as a bug hunter, also save time and you know immediately what's going on. But that's what I'm saying is, or that's why Google wants to advertise this. So even if you don't understand it, just use it, because it will help Google to immediately know kind of the impact of something. Yeah, and as I said, like XSS can be super simple to search for, and we like to use alert one because it's a visual pop-up. Now, since I made this video in January, as I said, there was just last month this blog from Albinovax about alert is dead, long live print, and I've actually never thought about this, but this is also pretty clever. In this video, we will talk about one issue with sandboxed iframes, and that you should use console.log, for example, but then it's not as visual and you need to look at the console and so forth. I didn't think about that you could also use print as a visual indicator that something was executed. When we get to the point, I will mention it again, but some people in the comments have pointed this one out. Obviously, it's kind of like now at the same time released, I say don't use alert one, and there's this article, alert is dead, long live print. They, in some way, are obviously about kind of the same issue, but the main issue is actually or the main concern for my video is knowing on which domain the XSS fires. That's the main thing. And this is about kind of like finding the XSS in the first place. So, for example, in terms of methodology, you could use XSS payloads that use print. And once you hit the print execution, then you can replace the print with a console.log to print the domain where the XSS fires, and you have to look in the console now to find the URL. Anyway, I'm getting ahead of myself. We get to that later in the video.
There are some browser client-side JavaScript frameworks with templating features allowing some limited form of JavaScript. And you can imagine that if you have...
Sorry. So this is the next topic, okay? So I just explained that it's very visual. But now we come to the second reason why alert is a good way to assess an impact or criticality about your injection. And here is why.
Client-side JavaScript frameworks with templating features allowing some limited form of JavaScript.
So maybe you have seen AngularJS before. In AngularJS, you write your HTML code and then you can have like curly braces in your code. Is it? Yeah. And then you can write some stuff into it. And you can write, for example, variable names. And these variable names are, of course, JavaScript variables that then can be printed or are then replaced and can be printed. And it also allows for some basic JavaScript. So, for example, you could maybe add a number like 1 + 1, or you have a variable counter, and then you do counter +1 or something like this, like very limited JavaScript. And you can execute the JavaScript, but the question is now, can you use full JavaScript? Can you like turn this into a full XSS attack where you have full JavaScript execution, or can you do only very limited, like, a small arithmetic printing a variable or something like this, And this is again also where alert helps you.
And you can imagine that if you have
sorry, I don't know how to pronounce your name, Tix. I thought it was called template injection. Yes, it is a template injection, but typically when you say template injection, you usually mean templates on the server side. And those template engines are different from your client-side template engines. Technically, it's the same thing, but technically, format string vulnerability printf in C is also a template injection. So yes, it is a template injection, but these words and all stuff are fuzzy. They have overlaps. God didn't bring us the gospel down in written stone and a Bible that tells us exactly what these terms mean. So, yes, it is a template injection, but it's a special form of template injection because it happens in client-side templating when the website is rendering and the Angular JavaScript, renders your website, in the browser. So it's not a template on the server. And yes, so imagine now you have like a client-side template injection, or let's say you don't even, it's basically a template injection. Like let's say you cannot inject HTML code, but you can inject curly braces, for example. Then what can you do with those curly braces in AngularJS, for example?
Input where you allow some restricted version of JavaScript, for example, printing some scope variables or doing basic math, then if you can inject this, it doesn't matter for security. You can't do anything evil with that. However, alert is a function that is part of the window object. And the window object holds the most critical data an attacker might be interested in. For example, the local storage, which might contain session tokens, or the famous window document cookies. This means executing alert can be an indication that your XSS finding has a high severity. But as a small side note, nowadays we mostly have given up on these restricted JavaScript templates as it was a cat and mouse game with fixes and bypasses, and we learned it's too hard. Check out the history on AngularJS sandboxing attempts if you are interested in that. I also have a small playlist about this.
So let's quickly go to the XSS cheat sheet. Okay, so let's have a look at these AngularJS things. As you can see, when you have a website with AngularJS, these older versions of AngularJS, so below Angular 2, so we are talking about Angular 1 point something. If you have content reflection in some kind of case, like a typical user variable is just placed into the website, then typical XSS would require you to be able to inject HTML. Okay, this is a bad example because there's another client side, it's Vue.js. It requires you to be able to inject HTML characters, like these HTML tags, the pointy brackets and so forth, right? Then you can turn that into an XSS. But the output might be perfectly filtered. Maybe you escape the HTML perfectly. But then you use a client-side language like AngularJS, which now, when AngularJS executes, it basically goes over your whole HTML code and is looking for curly braces. And when it finds curly braces, it does something to it. And in this case, it kind of executes the JavaScript within those curly braces. And suddenly you have JavaScript execution without having to use, a template, an HTML tag with an event handler or a script tag or whatever like that, right? However, but it's not that simple because they tried to implement the JavaScript sandbox where you can only access certain AngularJS variables, or you can only access, you can do basic math, 1 + 5, or a variable +5 or something, like very basic stuff. Maybe you can even call functions that you have defined. But it's all like very sandbox. The intention is only that you can call very specific Angular, things that you have written in your Angular app. But as you can see here, because this is still regular JavaScript that's getting executed, you can break out of your escape. So the original escape, basically that there was no sandbox yet, was going constructor.constructor and alert. And this is super easy escape to understand. So if you imagine that there's an Angular object, can I make this larger? When you add Angular to your website, the Angular script, you can imagine that I'm not so sure if it's called Angular, but you can imagine that there's an Angular object, right? Like that exists. And now when you write curly braces like this, Angular would turn whatever you write in those curly braces into a variable. So let's say on the Angular object is a variable called ASD. And now you write code that whatever is in the curly braces is printed. And if it's a variable that exists like ASD, it gets printed. So basically something like this would get turned into window.angular.asd. Okay? So that's kind of like how this templating stuff works. And it prints 1. So now on the website, you would print 1. But now the XSS payload here is like constructor.constructor. So let's see what happens. Angular is an object, and if you go to the constructor, you get the object constructor. And when you call constructor again, now you have the function constructor. This is just inheritance, object-oriented languages, right? And now that you have a function constructor, you can make it construct a function. In this case, we are constructing a function with the code alert1. Okay, bad example. This website is using CSP. That's unfortunate. Let's quickly go to... This created now a new function. And this function is an anonymous function. This function doesn't have a name, but the code of this function is alert1. If you look at this function now, you call it. So you have two curly brackets, parentheses at the end. Now you call that function, so you execute alert1. So this was a sandbox escape. There was not really a sandbox in this early version. So after this, suddenly they tried to prevent this, and then the cat and mouse game that I just mentioned in the video started. Now they really try to clean this code in order, so they tried to that you can't access the constructor. But I guess their first fix, you could still get the constructor on this on function and get the constructor from there. And then now you can see it gets really crazy. Now you make a variable A with the text constructor, an object B, and now you just go wild and you try to, access the constructor in different ways. This one is interesting because actually in AngularJS, this code is kind of assembled in text and then placed in like an eval script, and this simply was a bypass of that part. It gets injected into that text and then it gets eval, so you break out there. This is a bit more interesting, different strategy of sandbox escape than these ones here. Anyway, this went crazy. Look at this, how crazy these things were, because AngularJS always tried to fix again ways how people got access to the constructor or people got access to eval and so forth. Look at this, look at this one, Jan Horn, crazy. Yeah, but since 1.6, they decided, fuck it, this is too hard, this makes no sense. Let's remove the sandbox at all. Let's completely remove the sandbox. And so now you are back to the beginning where there is basically no sandbox. This is not really a sandbox. This is just using JavaScript. Long story short, I made a video series about these AngularJS bypasses. We looked at 2 of them, I believe, or no, 3 of them in detail, and we look at the bypass, the fix, and then bypass the next bypass and so forth. So if you're interested in this, I think even though it's an old series, and I know AngularJS 1.4 you won't see in production really that much anymore, not that important for bug bounty, I guess. But if you are interested in learning more advanced XSS stuff, the AngularJS playlist, I think, is, a really good learning resource in my opinion, hopefully. Anyway, we were talking about alert, and this is the reason why alert is great, because once you were able to execute alert, you proved that you escaped out of the restricted JavaScript, because alert is part of the window object. It's part of the global big window object that holds like all the important other data like the cookies or the local storage and so forth. So if you can access alert, that is proof that you escaped the sandbox, right? Just because, you could execute some form of JavaScript, but if you could execute alert, now you really got it, okay? Does that make sense? So this is the second reason why we like to use alert. Cool.
Anyway, even though it seems that alert1 is a great indication for XSS injection actually being critically exploitable, it's not a good metric anymore. Even if you see an alert pop up, it might not be a security issue. This might be a bit surprising to you. Why would an alert pop up not be a security issue? I hope I can explain that to you. And this is where alert document.domain or alert window.origin come into play. With those, it's much clearer for you to understand if you found a critical XSS vulnerability And so if you use that in a bug bounty report, then it's also easier for Google to review your finding as well. So let's investigate why this is the case.
Again, this Google Bug Hunter University made me more think about invalid issues. And I think it's a really good learning step you should be doing at some point when you are heading into IT security. Think about the cases, when are things not a vulnerability? I'm showing you now an example. Basically, I try to find an XSS on Blogger, and on first sight, it looks like I found an XSS on Blogger. But then I'm going to explain why it is not. I mean, technically it's an XSS. You get an alert, you execute JavaScript on a domain, but I explain why this is not a vulnerability.
Google's Blogger service as an example. Keep in mind the date of this video. Bug bounty scope information might change over time, but right now all subdomains of Blogger are in scope. And when you explore the features of Blogger, you might come across a feature that allows you to put arbitrary HTML into your own blog, which means you can inject a script tag with an alert 1. You don't know yet where or if it executes, so you continue to use the page. Maybe you write the blog post and then you hit the preview button and suddenly you see the famous,
holy shit, we found an XSS on Blogger. Look, the domain says blogger.com and there's an alert 1. We did it. We did it. While here you can already see a hint. In this case, the browser is actually telling us already some information here, but this is not always the case that it's there. And it's still important for a beginner in XSS. This is probably not clear that this is bad news here, because what it feels like is we use blogger.com and we executed an alert. This is, if you learn the basics of how websites were done many years ago, you know, there's the domain, you get an alert. This means there's an XSS on blogger.com, right? But the reality is just not done.
This XSS payload trigger. Look, the domain is blogger.com and that site is in scope, right? Give me bounty, please. Did we really just find an easy critical XSS bug on Google's service? Well, actually, we did not. To explain why, let's modify the alert 1 to the preferred alert document.domain and try it again. We save the new payload and preview the blog post again. The XSS triggers, but it shows the domain user_subdomain.blogspot.com. So why does this XSS trigger on this blogspot.com and not blogger.com?
So we alerted a variable. The variable was the document.domain. So we alerted the domain where this JavaScript was actually executed. This is the whole point of it. We want to know on what domain the XSS is executed.
The reason is simple. Look into the Chrome developer tools. This website, blogger.com, actually has an iframe where it embeds the user_subdomain.blogspot.com site. And the XSS is located on this domain, not on blogger.com. So no, we did not find a real XSS on the in-scope URL blogger.com. But hopefully you ask yourself now, why does Google use two different domains to implement the Blogger service?
And this is an important point. And this is also where, for example, developers, I believe, need to really have a bit of web security understanding. This is a good architecture reason why Google is using different domains and subdomains to implement this, right? You could have a blog, like if you naively implement a blog, how I would maybe have implemented a blog a while ago for different users. You could have blogger.com/ and then the username, right? Like on Twitter, blogger.com/ liveoverflow. This could be my blog. The problem is, as soon as you allow to customize this blog and allow HTML elements like Blogger allows it, then if it would be on the same domain, that would be an issue because now you can XSS the whole domain. And so here there was a smart security decision being done where they decided we need to put the user controlled content, the content where users can actually add arbitrary HTML and execute their own JavaScript. that has to be on a different domain. And if it's a different domain, it's a different website. And the same way how your attack website, evil.com, cannot just attack facebook.com, this way blogspot.com can, or xsstest.blogspot.com cannot attack blogger.com. So these are completely two different websites, and XSS is it the only reason? It's pretty much the only reason, yeah, why this is being done.
Well, XSS is a reason. Google uses a range of sandbox domains to safely host user-generated content. Many of these sandboxes are specifically meant to isolate user-uploaded HTML and JavaScript and make sure that they can't access any user data. So what exactly does that mean?
So this is a really confusing concept. This idea of sandbox domains, when I started to hear about this, I didn't really understand what sandbox domains means. But at the root of client-side web security, so if we talk CSRF and XSS, at the root of that lays the same origin policy. Only websites from the same origin, or like the same origin, only can talk to each other, right? Your own website, the HTML can issue API request to your API on the same domain. The same origin policy has some quirks. You can send GET request. So on my website, I can add an image tag and load an image from a different domain. So the same origin policy does not prevent me to load an image from a different domain. So I'm still sending a GET request to that. But it's not as easy as sending a POST request. Now, POST requests can be sent, but I cannot, for example, control the content type of that POST request. So if you, for example, if your API requires or takes only JSON, by default, you shouldn't be able to make a POST request cross-origin, and so forth. Of course, there are a lot of footnotes, but in principle, we can say that websites are isolated from each other, and websites can only act on their own website. And that's why as soon as you have user-generated content, here they say, if there is user-uploaded HTML, JavaScript, or Flash applets, so basically any dangerous, more interactive website stuff, it has to be isolated and has to be put on its own domain, on its own website. And that's what we use then, the subdomains for. So whenever you build a service where users can add their own HTML or JavaScript, you need to put that on their own domains. Otherwise, you will have basically endless war. A sandbox domain would be an iframe. Was a question in the chat. No, a sandbox domain can be, the domain can be added as an iframe because it's a sandbox domain on the same page, so it looks nice. But a sandbox domain is just a different domain. You have your main domain, like you log in on that domain, or your API is on that domain, or the payment stuff is on that domain. But when you have user-generated or users that can upload HTML, it has to be on a different domain. Think about Amazon S3 and websites hosted on Amazon S3. When you actually want to host your website, you need to use, the version with the subdomain, so that you have your own subdomain and your own domain. Otherwise, if every file on Amazon S3 would be available from amazons3.com/a-path, then you could never host your blog there, because if you have a login there or something, or cookies, other people could upload an HTML document and could interact with this data. You know what I mean? So whenever you have the ability for users to upload HTML or JavaScript, you need to put this on a different domain, and then you call that sandbox domain. Sandbox is a term that we use to say it's an isolated environment, it's a restricted environment. So those different domains that we use to host user-generated content, so it can't do harm in terms of CSRF or XSS, we call that then a sandbox domain. Does that make sense?
attack is to access stuff you shouldn't have access to. For example, the cookies of another user. But the cookies are on the blogger.com domain, so XSS on user subdomain.blogspot.com cannot read those cookies.
And this is basically why you alert the domain and why the triager at Google wants to know where your XSS executes. Because if you see an alert pop up with the domain blogger.com, you know that you can access all the critical data. But if the XSS executes on this domain, then you know this can't do much, right? And it's user-generated content anyway, so it's kind of the user's problem of that domain. That's why the triager immediately knows the impact. I had a bit of a discussion on Twitter regarding showing impact of XSS, especially in bug bounties. There's always this conversation, you need to provide a proof of concept to show impact, And that is important, but only once. Once there's one example, like the developers of Blogger or Google triagers, once you understand what the capability of XSS on blogger.com can do, you don't need to reprove it. You don't need anybody else to write the proof of concept. You understand now that XSS on Blogger is critical, and so you don't need to reprove that. Alerting blogger.com, the domain, is enough. You know, oh, it's on blogger.com. Oh shit, that's critical. That's fine. And so with bug bounty reports, I understand, like if it's a new client, a new bug bounty program, they don't really have a security experience yet, and they want to have a bit of knowledge with bug bounties. Maybe they are not aware which domains are really critical for them, right? Because they have multiple domains. They have the dev.something domain. They have the API.something domain. They have the whatever.something domain. So they have a lot of different domains, and one part is hosting their JavaScript. One domain is holding the local storage. One domain has cookies. So they don't really, they should know, but maybe they don't know yet the impact of it. So as a pen tester, if you do an audit, or if you're a bug bounty hunter, you need to show them once, this is your critical domain. Here's a proof of concept. Here's an example. This doesn't have to be a full XSS though. You can, just by looking at, which domain has the cookies, which domain has the local storage, and so forth. This allows you to already assess, okay, this is the critical domain, without having an XSS in the first place. But once you have an XSS with the proof of concept, that's good enough as well. Anyway, what I'm saying is that once one bug bounty hunter showed that this domain is critical with one proof of concept, all the other bug bounty hunters coming after it shouldn't have to write a proof of concept again to show that this domain is critical. Basically, in my opinion, I think for bug bounty programs, it would be easiest if they list all their subdomains or domains, and they write behind it how critical it is. Because there will be subdomains where the XSS doesn't really matter. For example, a lot of websites, when you upload an image, an avatar, that image is then put on a static host. So it might, for example, be put in an S3 bucket, and you host the image there. But the website itself runs on a different domain. It just uses S3 for the image. Now, oftentimes, you can actually just upload anything to S3, and you can upload an HTML document. And this HTML document can now have JavaScript. And now you have an XSS on the domain of this website. But the impact is basically zero, because this XSS cannot do anything on the main domain because it's on the S3 bucket, right? So I guess that's also why they exclude the domain from the program. With S3 buckets, I guess it's clear, but it could also be their own service. Maybe they have an image.website.com and where they host static content like this, and you get the point. So I don't know where I started with that. What I'm just saying is that once they should list their subdomains and write after it, this is the critical domain. If you find XSS here, this is critical. And if you find XSS here, it's annoying. We would like to not have it there, so it's a medium or low. And here are sandboxed subdomains, and XSS on there doesn't matter. Does that make sense? And a bit unrelated, that has to do with a different video I made before. If your only argument is it's phishing, it's not a valid issue in my opinion. That is not a vulnerability. If it can only be used for phishing, in my opinion, I'm feeling pretty strong about that. It's not a vulnerability.
It's simply not possible, thanks to the same origin policy. These are considered two different websites. And that's why we want to look at the document.domain or window.origin in the alert, because it tells us on which domain this XSS is actually executed. It tells you what data can this XSS access. And it can only access stuff on user-subdomain.blogspot.com. Google wanted to allow users to customize their own blogs and allow them to include arbitrary HTML and thus JavaScript. But they also want to make sure that this cannot be used to attack other Blogger users via an XSS. Thus, they put the user data on this other domain and embed it via an iframe. So, when you see an alert pop up, make sure to do it with document.domain or window.origin, so you can check if your XSS triggers on a critical domain or on an unimportant sandbox domain. This decides if you found an actual security issue or not.
Exactly. If you show the domain, the triager at Google knows exactly this domain is critical, and so it's a high severity XSS issue, or this domain was a sandbox domain, this was not an issue, right? That's why it's important.
Now, besides sandboxing via actually different subdomains or origins, there exists also the concept of sandboxed iframes. I have introduced this before in a video I made, Google Script Gadgets, Google Docs XSS vulnerability walkthrough. Here, Google implemented a so-called JSON-P sandbox. They basically injected an iframe with a user-controlled XSS payload, but also set the sandbox attribute on the iframe. To better understand this, let's do some experiment with iframes.
Okay, this is always the pacing is difficult in videos, but we have now talked about the sandbox domains. So we can use different domains to host user-generated stuff. The same origin policy prevents those websites from communicating. That's why having JavaScript execution, having an XSS on certain domains is more critical than on other domains. On some domains, like sandbox domains that are intended to run JavaScript, it's even not a vulnerability at all. So now let's talk about a different approach, how websites can deal with executing arbitrary JavaScript. We already learned that we can put arbitrary HTML or JavaScript user-uploaded or user-controlled data onto different subdomains. Like Blogspot is using a different subdomain for every user, okay? So we learned one thing. And now we come to a different case, which is a technique, for example, used when you have JSON-P endpoints and you want to add kind of a layer of protection against JSON-P endpoints. Yeah, so here's this kind of a fun example. So here we are basically implementing arbitrary JavaScript execution, like XSS by design, but we nullify its effect so that it's not becoming a security issue. So, and this is what you can do with a fairly new feature in iframes, where you can set a sandbox attribute on the iframe, and this changes the capabilities of JavaScript in that iframe.
Different subdomains or origins, there exists also the concept of sandboxed iframes. I have introduced this before in a video I made, Google Script Gadgets, Google Docs XSS vulnerability walkthrough. Here, Google implemented a so-called JSON-P sandbox. They basically injected an iframe with a user-controlled XSS payload, but also set the sandbox attribute on the iframe. To better understand this, let's do some experiment with iframe sandboxes. I've implemented here a very simple tool that allows users to execute JavaScript expressions via eval. You can write 1 + 2 and it prints the result 3. You can also see here a secret session token, and of course it's no problem to execute alert document.session to prove that you can steal the secret session token.
So this is maybe an innocent example, but it's kind of showing the point. A website where you can just eval something doesn't make, like, it's technically a vulnerability, but not really a vulnerability, right? Because you can't do anything on it. The website needs to have something special about it, right? In this case, it's like a secret that you want to take from the website. it could be the private messages of the user that you attack or whatever, right? Like you need some kind of secret. So I just added this so to say, look, there's an XSS and our goal is to access the secret data. Okay, so that's the premise of this story here. You have a website with secret data and you want to have an XSS that can read that.
But look at the second example. It has essentially the same features, but this time the script being executed is inside of this iframe, which also has a sandbox attribute. But ignore the implementation details, try to execute alert again. And you see it works. So is this equally vulnerable?
So this is kind of a bit of a, tricksery with the example that I mentioned in the beginning, that when you can execute alert, then you access the window object, which contains all the important information. So traditionally, you could say that, this is a serious XSS issue, right? We executed alert and it's an issue. There was also a question earlier. Sorry, I ignored the question until now because now it's fitting. Somebody was earlier asking, isn't using alert a bit pointless since every browser nowadays, so alerting the document.origin, document.domain, window.origin, every browser nowadays has an alert window that has a title with the origin. Well, look at this. If it's now an embedded iframe, it doesn't show you. Yes, of course, if it shows this, then you know it's an iframe, but you still don't know like the alerting the document.origin is just good habit, and it will tell the triager in any case what the domain was. So it's not really pointless. Again, this is like tips for a kind of a beginner XSSer who doesn't really understand things yet, and who might fall for a false XSS issue, like an invalid XSS. If those people just start early on using the document.domain or window.origin to print the origin, it will be for a triager or anybody else that this person asks for help will immediately be able to tell did you find really an XSS issue or not. Yeah, it's kind of an anonymous origin in this case.
As the previous example? No. Try to alert the secret session token. It won't work. And to see why, simply use the preferred alert document.domain or alert window.origin, and you will see that it's empty. This is a bit different from the sandbox subdomain Blogger uses, but you can see that this sandboxed iframe also has a different origin.
So even if this like this iframe sandboxing is weird to you, if you think of web security in the terms of origins and the same origin policy and the different origins, so different domains cannot access each other, like if you remember this principle, then this kind of explains to you how the sandboxed iframe is protected, because it's a different origin than the parent website. So this is kind of like a way how you can understand this for yourself or explain this to yourself. It's a different origin. So of course, this iframe, the JavaScript executed in that iframe cannot access the code in the parent.
Over their weird origin. It is isolated.
Could this iframe access document.cookie or local storage? No, because as you can see, it tried to access document.session. So that's not different from document.cookie. It cannot, because it's not executed in the context of this website. It's executed in the sandboxed iframe. It's executed in a different website. It's executed on a different origin, a different domain, so to say. That's the whole point of these sandboxed iframes. You isolate it from the actual website.
From the website it is embedded into. You cannot steal the secret session. So this achieves the same isolation as the Blogspot subdomain did. This alert would not be a valid security issue. That's why you always want to alert the document.domain or window.origin.
And so here again, like if you understood this topic or not, doesn't matter. If you want to hunt for bugs on Google, you can do that even though if you don't understand this. What's important is just use document.domain or window.origin, because if you then find something and you send that into Google, they know immediately, was it a valid issue or is it like one of these weird and complicated cases of sandbox stuff that is really difficult to understand, like at first. Like this took me also a long time to get a feeling for what it means to have a sandbox iframe, a sandbox domain, and why alerts here are not a vulnerability, right? It's helpful for everybody, especially the triagers, if you use document.domain, because this just tells them immediately if you found a valid issue or not.
But before we end this video, I want to give you another tip when hunting for XSS issues. First of all, if you find an injection into a sandboxed iframe, it's uncommon that allow modals option is enabled. For example, here on sites.google.com, you can also create your own website and embed a raw HTML code.
So here's another example of a Google website like Blogger that allows you to create your own websites and customize the HTML. So again, on sites.google.com, you can also insert JavaScript here. So let's see.
Similar feature like on Blogger. Thus, you can also embed a XSS payload. But when you try it, nothing would happen. However,
okay, so see, now you don't observe an alert and you could think, oh, there's no XSS. Now, again, here would be nice to have, talked about the print. Again, I made this video a few months before. I hadn't thought about this. So I'm showing here a different tip, but definitely you would do a two-step thing. You would first now hunt with print. And once that triggers, then you do what I show now here.
If you are an experienced bug hunter, you might always have a look at the dev tools, and then you might notice that alert is blocked due to a sandboxed iframe. So in this case, it would be better to use console.log to actually see where or if it is executing your XSS payload. But this means you need to pay very close attention to the console output of the DevTools. Maybe use filters to quickly identify them. As you can see, hunting for XSS can be a bit more cumbersome. Anyway, we did execute JavaScript and confirmed that by executing console.log. So did we find an actual XSS on sites.google.com?
We found another XSS on a Google domain. This time it's even like a cool google.com domain, not fail useless blogger.com. So
that would be in scope, right? Do I get a bounty now? Well, again, we want to look at the actual execution context by looking at the document.domain output. And when we change our payload to that and look at the page executing this payload again, you see that we are on another sandbox domain.
See here, Google has their own domain. It even says in the name Google user content. So this is a domain by Google, but it's used to host user content. Users control the content on here. But still to isolate each user from each other, to not have them XSS each other basically, they put it on a unique subdomain. I assume, I haven't really researched this to be honest, but I would assume that this is unique to your user.
This time googleusercontent.com. So no, this apparent XSS is not really a vulnerability. It's by design put on another domain to make it harmless. So now that you know how to identify when a XSS is invalid, you might ask yourself, why should I even be interested in further investigating a XSS in a sandboxed iframe or on a sandboxed domain? Because it doesn't qualify for a bounty, right? When you have, for example, an injection into a JSON-P sandboxed iframe, the actual site usually communicates with the iframe via post messages.
So yeah, now I'm just giving some, just because you find an XSS on an invalid domain, you should take notes of it, because modern websites can be very weird and complicated, especially crazy apps, like Google Drive or Google Docs or something like this. There's so much going on. There are so many iframes interacting with each other. And if you think about an XSS that is executed in an iframe, why would websites use iframes? They typically want this to isolate stuff, or they embed some external service. So maybe they embed the Facebook like button or the PayPal checkout page or something like this, like some external iframe maybe. And on this iframe, you maybe find the XSS that is executed in this iframe. Now, typically when people embed iframes like this, there's maybe code that interacts with this iframe. So they do define through post messages code that can be, executed here and there. And so while the XSS itself here doesn't do anything. If you actually can show that you can break out of this sandbox, if you can break out this this iframe, if you can use the post messages to execute code on the real website, then you have an issue again. So this, but this, then we talk a bit about a different like vulnerability. At first, it's not. I said earlier, and this is still the case, that based on the domain, you know the severity, and this is generally true. But of course, you might have additional issues where a person could jump with the XSS execution to a different domain just because now they are in a place where they can now send malicious post messages to a different origin, and then something else can happen. So you can, of course, always dig deeper, and maybe you show Google or you show a bug bounty program that they thought that this domain wasn't critical, but actually they made it critical because they implemented some insecure messaging or something like this. So that's why still take notes of it. Maybe you can use it in something more complicated or in a chain of bugs, which also is the same with open redirects. Open redirects by itself are not a vulnerability, but you should take notes because they might be useful in a combination with other vulnerabilities to have a chain, a full exploit chain, and achieve something more. The same with sandboxed iframes, sandboxed subdomains. By itself, they don't present a vulnerability because it's by design intended. It can't do anything. But if you can combine it with other stuff, like an insecure message handling implemented there, then yeah, you have a valid bug. You combine it with something and you made something out of it. That's why you shouldn't feel bad if you find an XSS on here. Just take notes of it. Maybe you have some cool ideas later.
And so there could be a way to exploit a message to get XSS on the actual site, basically doing a sandbox escape. But in this case, the vulnerability is not this first XSS. The vulnerability is the escape out of it. So reporting the sandbox XSS itself does not qualify for a bounty, but it means if you can somehow chain other bugs escalating it and execute JavaScript on the actual in-scope domain, then it would be a valid issue you can report. But you see, those are really advanced XSS issues, so make sure you really understood it and don't just report invalid XSS findings. So to summarize, most important for you to remember is that Google intentionally allows XSS by design on sandbox subdomains or sandboxed iframes. And a simple alert is not proof enough that you actually found a serious XSS issue. You should always look at the actual domain the XSS is executed on by using a payload like alert document.domain or alert window.origin. Hopefully now you understand why sandbox subdomains and sandbox iframes are cool, at least for defense, but unfortunately that also means an XSS on there is not actually a security vulnerability that a bug bounty program would pay for. I know it kind of sucks when you see an alert trigger, but it turns out to be on a sandbox domain. But if you find such an invalid XSS, be happy anyway. It could be useful for a longer chain, so take notes and remember where you found it, but also understand that by itself, it's not a valid issue. And now, good luck hunting.
What did you think about my move at the end? I was like doing this a few times until it looked the least cringy.